Right, so this is lecture 4 on Android development. So we've got 2 more lectures left, and then your first assignment's due in, which is going to be the lecture notes. Don't take a nap, okay? Don't say we're never original with these projects. So a couple of outcomes for today. We're going to look at activities and intents. That's how we launch multiple views in Android. That's the equivalent of a navigation view. Options and action bars, there's your menu items. Okay, and we're going to talk about list views. Okay, how we get stuff displayed on the screen. So there's quite a bit to cover today. Okay, so start off with some concepts. Activities. Any screen that has interactivity on it is an activity. Okay, and the idea is, up until now, you've only had one activity on your applications. Okay, we've looked at controls, we've looked at Java, we've looked at the basic IDEs. Now we move on to more complicated applications. And the idea is, not only do we need to have multiple activities, we need to be able to pass data backwards and forwards between the activities. Remember when we first started, I talked about the model view controller, and the idea is each activity needs to be independent. So we need to have a way of passing data between views where the views don't need to know about each other. The equivalent of segues and exit segues. Okay, so that's where we're going to be today. It's done in very different ways. Now, the difference is, with activities, there is no navigation bar. There's no nav bar controller at all. As soon as you start piling activities up on top of each other, it automatically adds the back button at the top for you. You haven't got to embed anything inside an UI navigation controller. So there's no root view controllers or anything like this. It's much simpler. And the idea is, as soon as you start piling things up on top, you get a back button, which allows you to go back to the previous view. And all it's doing is throwing away the current activity. So the back button simply chucks the activity away, and we need to make sure we can get data back before it disappears. So remember, you need 2 files for every single activity. You need to have your view and you need to have your controller. Okay? And also, we need to add the views to the manifest. Anyone had a peek at the application manifest yet? Okay? You haven't had a look at that yet? No? There's a manifest.xml file in your application, and every activity needs to be listed inside there. Otherwise, when you try and launch it, it'll crash. Unexpected error. Programs had to close. So if when you're testing things out, when you hit a back button or launch an activity, everything just kind of goes bang, have a look in your manifest file to make sure there's a reference in the manifest file to the activity. So really simple. I think this is the old version actually. You simply add a new activity to your project. Some reason I've left, this is the old Eclipse version. So when you add a new activity, it'll give you the view, it'll give you a menu file, and it'll give you the controller. So it'll actually give you a third file, the menu file, which we'll talk about later. So this is how we add new activities. And let's have a look at the manifest. The manifest is normally called Android manifest.xml, and the manifest controls what comprises this program. If you try and do something which isn't in the manifest, it'll crash the application. And it's kind of important because, let's go back a minute, because unlike iOS, where you have the view controller, you have your navbar controller, you have your views inside there, there's nothing explicitly linking those views together in the application. They're just independent views which happen to be in the same project. So the manifest kind of explains, for instance, when you launch the application, which view gets launched? What's the default view? Because it's not like you've got a storyboard. Yeah, each view is completely separate. So you need to be able to identify the launch view. You need to be able to identify what are the views you've got, the permissions the views have, and so on. Now, the trick here is, because we've got no navigation bar controller, we need to be able to pass data across to the next view. We've got no nav bar controller, we've got no segues. We haven't got any nice thing where you can just say prepare for segue and off it goes and does it. We've got to do things the hard way. Okay, this is Android. Yeah, a real man's programming language. No easy shortcuts, no control drags. So, challenge here is when we're in our first activity, we need to have some way of launching another activity and placing it on the top. And when we do this, we use something called an intent. Okay, bizarre terminology, but intents. There are two sorts of intents. There are explicit intents, where you say, I want to launch this class. I want to launch this controller. And there's implicit intents, which say things like, I want to take a photograph. I want to look at an address book. An explicit intent always launches that exact class that you specify. An implicit intent, it allows the operating system to decide which application should respond. So when you say I want to take a photograph, there's probably 30 different photo apps available on the App Store. When you install the photo app, it registers that you can receive certain intents. This app allows you to take photographs. So when you say, I want to take a photograph, the operating system hunts through all the applications it's got installed and comes up with the most likely candidate. Okay? It gets around this problem of where you've got lots of different options to do the same thing. So you can install whichever photo app you want to install on your Android phone, and it will always launch that app. Think about the problem with iOS with Apple Maps and Google Maps. You might want to use Google Maps. When you launch a map activity, it always launches Apple Maps, doesn't it? Yeah, Android gets around that problem by choosing the most appropriate one it can find. And if you look at the code, this is how an explicit intent works. So I've just put it in a click. Yeah, so I've got a button click here. Now look at it carefully. Can you see I'm creating a new intent object? Okay, and there's two parameters. The first one is what's the current context? Where are we at the moment? And that's this particular class. And the second bit is which controller do I want to load? Anyone tell me why it's education.class, not education.java? Because when you create your classes, they're education.java, aren't they? Why have I suddenly got a .class extension instead of .java? Hazard a guess.
Because it's explicit?
Not quite. What do you have to do to your source code before it'll run? Once you create your source code, what do you have to do before it'll run on the phone? Think about C++ or any of these languages. You have to compile it. Yeah, you have to compile the source code, don't you? Into machine code or Java virtual machine code. The .class extension is the compiled version. It's the bytecode version of the source code. Even though you don't see it in your files, that's what it becomes once you've compiled it, a .class file. And then right at the bottom, we simply call a special method called startActivity, which is part of the view class. And that will launch the activity. And of course, when you launch the activity, the class file, view.load, specifies what the view is, doesn't it? It tells it which XML file to use for its view. So that's a simple way of declaring an intent and launching the second view. But of course, there's no way to pass data at this point. We need to be able to pass data backwards and forwards. Okay, now let's look at how we pass data. This one is almost the same. The only difference is I've added one extra line here, which is put extra. The intent allows you to bundle extra data in with the intent before it launches. So you simply add the data to the intent object, and then when the application launches, you can extract the data in your second view, your second activity. Now notice the format for put extra. It's the dictionary, isn't it? It's the key value pairs. So we're simply adding new keys to our dictionary. And you can see this one, the key is message and the message is hello. And when I start activity, that data is then available in my next activity. And I can, in view.load, on create rather, I can actually access all the data, can't I? And in fact, here we are, look. Next slide. So on create, trick here is that if statement. That will stop your application crashing. It's saying if there's some extras, if we bundle some data in there, let's get the data out. Because remember, each of these activities is supposed to be completely independent. If we were to accidentally launch this activity from a view which didn't pass an activity which didn't pass any data, we don't want it to crash, do we? So it's a good idea to check to make sure there's data there. So we simply, now look carefully above that, after we loaded the view, we create a new bundle object. In that bundle object, okay, we can simply use get. Yeah, get string, get int, get float, get bool, and we can retrieve the data we passed in there. So it achieves the same thing as the segue, prepare for segue, but instead of having public properties in the second activity, like we did with iOS development, we simply created an object and passing the whole object across to the next activity. And because of that, you've got to be extra careful that you test to make sure the data is there before you try and access it. Okay, remember, defensive programming is the key here. Make sure you can access the data's there before you try and pull it off. And as you can see, it's dead easy, isn't it? You just access the data, extras get string, and then you've got your data. So that's how we pass data from an activity to a sub-activity. That's the first step. Now, if we want to return data back to our main application, let's think back to last term. We had to create a method, didn't we, in our first activity to listen out for data being passed back. Remember that one? Remember the exit segue? You created this special segue, and you could pass the data, and it got triggered when the data got passed back. It works the same way in Android, believe it or not. The difference is, well, what is the difference? There's only one line which has changed. See if you're awake or not. The last line. What was it before?
Start activity.
It was start activity. If you want to return data, you have to call start activity for result. Okay? And that flags up that some data going to be coming back from that sub-activity. Now the request code is simply a constant which I've created. Every start activity result has to have a unique integer value. So when you get data coming back, you know which activity it's come from. And all I do at the top of my class, I just declare it as a constant. So request code is just an integer value of 1. Okay, so I've declared my request code. Let's go back to there a moment. So I package my data up. I start activity for result. And then when the activity closes, I want to be able to capture that data coming back through. So let's see how we do this. Right, first of all, there's a special method called finish. And what that does, it gets called just before an activity disappears. So literally the last thing that happens before it gets wiped out of memory. So what happens is when I hit the back button, there's lots of events happen, and the last one that happens is finish. So when you hit the back button, we can capture that and send the data back before it shuts. If you didn't do it that way, you'd have to have a button that says close or something, wouldn't you? Which wouldn't really help. So this way we can capture that back button being clicked and we can send the data back. And as you can see, well, anything look familiar in that? What's going on? Any familiar code? Nothing? Rewind about 3 slides. Get extras, or rather put extras. So we're doing exactly the same thing but in reverse. We're creating this intent again, we're putting the extras, we set result, that's really important. Because sometimes you hit back because you want to finish and you've done what you want to do, sometimes you want to cancel. Now result OK says actually I finished what I want to do and I'm OK with the data. If I had a cancel button on my second activity, I could say set result, result cancel 1. And what that will do, it will send a message back to my first view that actually I've cancelled the operation, I haven't just said it's OK. And then we can pick that up in our first activity, and obviously if it's result OK, we can perhaps save the data. If it's result cancel, we can say a little toast message, data cancelled, and do something different. So you've got a way to handle cancelling and finishing at the same time. And then, of course, because it's a subclass of activity, we have to call the finish method of our superclass to tidy things up a little bit and wrap things up. Now look at this one. This is the equivalent of our exit segue. This is the code that gets fired when an activity closes. And if you see, there's 3 parameters for this method. The request code, remember each request had a separate number attached to it, so we know which request is finished. The result code, which is result OK or result cancel. And the intent, which contains all our lovely data we've just passed back. So there's 3 things. Request code, the code we specified when we launched the activity. Result code is OK or cancel, depending on what you specified. And the intent is where our data sits. So we've got everything we need. So my little first if statement says, does the request code match my initial request code? Well, it should do because I've only got 1. But there might be lots of different sub-activities, and each one will have a different code. So you need to detect which one's just cancelled. If it's the correct one, look at this if statement. This will save your bacon many times over because this allows you to check to see if the data's there before you access it. If i.hasExtra_reply, has it got in the extra bundle a key of reply? Is there some data under that reply key? And if so, I can just pull it out and display it and do what I want with it. So we can pass data to a sub-activity. I don't like the word sub-activity because in actual fact the activity is on top, isn't it? Super-activity maybe, a better term. And then when we cancel that activity and we throw it away, we're passing data back to the original activity. So the functionality we achieved with segues and exit segues, we've now achieved using intents in Android. Okay, so our main activity, we have to have some way of launching the second activity, and we have to have a method that handles any data passed back. That's just a quick summary of what we've just been talking about. So the main activity, launch the sub-activity, and listen out for any data coming back from the sub-activity. Okay? Now, this is useful. If you want to cancel an activity, the back button, okay, automatically fires up this finish method, doesn't it? If you want to have a button that cancels something, all you've got to do is call that method, and that will close the current activity. I thought I'd put that in there just to give you more flexibility. As soon as you call activity finish, it will close the current activity, and therefore it will trigger that finish method. Okay, so everyone okay so far? You understand the idea of creating activities, passing data to an activity, and listening out for data being passed back. Because fundamentally you're going to need that for your assignment, aren't you, to be able to pass data backwards and forwards. Okay, options menus and action bars. This is kind of interesting stuff, right? Now, in Android, there are built-in menus. Unlike iOS, where you had to sort of add your own buttons to your toolbars. There are options menus and action bars, which is, you know, if you've got an Android phone, you know you've got the menu at the top of the screen that drops down, and you've got the buttons across the top of your screen. They're the same thing. They're just displayed differently. You've got context menus, which is when you press and hold and something pops up on the screen. And you've got pop-up menus, okay, which we're not going to cover today because no one uses them. Okay, so we're going to look at how menus are created. Now, if you're an options menu, basically, let's go back a minute. Okay, an option menu appears at the bottom of the screen. Do you know what I mean? You know when you or at the top of the screen, depending on which way you want to, or which version of Android you're using. And the idea is, the options menu is actually an XML file. That's all it is. Do you remember that code in your controller which says on create options menu? Remember that? There were 3 methods, weren't there? Well, that's the method that generates that options menu. It's like on create, but it creates the options menu instead of the main application. And what it does, it loads in an XML file that you've created. And the XML file defines all the different entries and the icons that are in your menu. Let's have a look. Okay, forget that one. Let's have a look. Right, there we are. You need 2 methods to do menus. You need a method that will launch the menu, or you need a method that will listen out for anything that's been clicked on the menu. So by default, I think you've got the top one, haven't you? And you can see I'm inflating a menu called r.menu.activity_main. That's my activity main.xml file in the menus folder. Okay, now, and what that means is when you click on the menu button, anything that's in the XML file is going to get loaded up and displayed on the screen. The second one is what happens when you click on the menu item. Now, can you see you've got a menu item passed as the parameter? And you know how when you created your views, every controller had an ID, didn't it? You identify it. Well, in the menu XML file, every menu item's got an ID as well. So all you've got to do is have an if statement to see which of those menu items has been clicked on. Yeah, so in this case, I've got an ID of add on one of my menu option items, and I can just detect if it's been tapped on. Now, action bars. This is an Android 4 thing. This is the latest way of handling menus. In the old versions of Android, there was a menu button. There was a hard button, wasn't there, at the bottom of the screen. And the menu kind of popped up from the bottom, with or without icons. In Android 4, the menu is now at the top. And there's my menu. It's a menu that doesn't look like a menu. It looks like a button, doesn't it? That is a button on the action bar. In actual fact, it's part of the menu XML file. The idea is, if you've got a big screen, you want to display your menu options as buttons. If your screen becomes smaller, those buttons automatically turn into menu items. So you can handle tablet-sized devices and smartphone-sized devices with the same menu file. So what I do is when I set this up, I tell Android what I prefer it to be. I can choose it to prefer to be a button, I can choose it to be a menu item, or I can say, if there's space, make it a button. So the really essential items, you will say, this must be a button. The less essential, you will say, well, actually, if there's space on that action bar, let's stick them in as buttons. If there is no space, turn them into menu items. So you can prioritize what the user sees. So as you can see, or possibly, I think this foot's a bit small there, you can see that in the XML file, I've just simply got a series of items. Can you see that? And can you see the property which says show as action? That's the key. Always means it's always there. Yeah, you can see, look at the options on the side there. Yeah? Never, always. Generally the thing you want are never, always, and if room. Yeah? So always a button, never as a button, always as a menu item, or display as a button if there's space. And as you can see, in the XML file, each of the items is an item tag. So it's very easy to add new items to your menus. And menus are a key component of Android applications. Users expect to interact with menus when they use the application. So it's a very different way of thinking than with the iOS. Okay, so all you'll find is in your folders, there's a folder called menus. That's all there is to say about it. In that folder, you will find all your menus. You can create your own. Because remember, on menu item on the menu create, you can specify the XML file you choose. So you can even have contextualized menus depending on what you want to happen. Okay, so you can load menus in and out as required. Actually, before I finish off, is everyone happy with that idea, with menus? Simple concept, and generally that's how people interact with a lot of the application. The third item, okay, is list views. Here's your list view. Okay. Unlike iOS, the list view you have to drag it onto an activity. Okay. So this is equivalent to the table view controller, or the table view. Now, for this to work, we're going to use something called an array adapter. And the idea is this is the connection between the data and the list view. This is the key. Basically, you create an adapter between the two, and when you add items to the array, it will automatically add them to the list view. There is no data source. There are no delegate methods in Android. Okay, so instead of delegate methods and data source methods, we use adapters. There's an array adapter and there's a data adapter if you want to use a database as part of the application. So when we create this adapter, there's three things it needs to know. The context, which is generally this, because that's what it always is. The list item layout you want, and the data you want to feed into it. So you've got these three parameters. Let's look at an example in a minute. Okay, so two adapters. We're going to cover the array adapter for this assignment. We're going to cover the cursor adapter for the next assignment. Because the next assignment we're going to use SQLite as our database, backend database. And we need a cursor adapter for that. So let's have a look at this one. Okay, so this is how we set up our lists. Okay, so we find our list view, find view by ID. We've always done that, haven't we? We create a new array adapter, and can you see the three parameters? This, the Android layout we want to use, simple list item 1, which is the default one. So answer some of your questions. We have to create custom ones. And the data source, which is our books array. We set the adapter, we set an item click listener, and that's it. We're finished. So we create the list, we get a pointer to our list view, we create our adapter, we assign the adapter to the list view, and then we can set our clicks, our click handlers. And the on item click, can you see the parameters there? Can you see we've got the view, which is the list item. We've got the position starting at 0 from the top. Okay, and we've got the ID of the cell. So once we've got that, we can retrieve the data and do something with it. So adding data to the list view is really easy because you simply create this adapter and then modify the array. And as you modify the array, it will automatically update the list view. Detecting which one's being clicked on, the important thing is this position, this integer, which is the position that's being clicked. So if you think about it, if you've got an array where the indexes start at 0, and if you've got a list view where the indexes start at 0, you've got a match, haven't you, between the two, so you know which one's being clicked. And to add items, you just add them to the array, and then you have to tell the array, tell the adapter the data's changed. So you add the item to the array, and then you call notify data set changed. Okay, that's kind of like refresh, isn't it? It just refreshes the view. So, everyone happy with that? We've covered three things. Yeah, we've covered creating activities, raw activities, and how we pass data backwards and forwards. We've covered menus, how we add menus and create the buttons. And we've also covered list views, how we add and remove data from list views. Okay, so that should be enough for you guys to start working on your next assignment if you haven't started already. What we're going to cover next week is we're going to look at some data persistence, how we persist the data. Okay, we're going to persist it to a file just like we did with iOS. Okay, when we do the advanced Android, we're going to look at databases, SQLite databases, which is the equivalent to core data. But for now, we're just going to work with file-based data persistence.